Hello, my name is Christopher Hayes, and this is my final project for ECE-178, VGA display of SD card data. First I'll be going over the system setup, which contains the SD card IP core and the VGA controller setup, which are both modeled in the QSys design software. The assembly program's main function just involves reading the SD card and displaying it on the VGA monitor. And finally, I'll provide links to the references I used while making my design. System setup: the SD card IP core and the VGA controller. This shows some general information about the SD card controller IP core. The table to the right shows the register map and the offsets used, and the main 512-byte buffer is where all the incoming or outgoing SD card data is stored. This controller core abstracts the SPI protocol, greatly simplifying the SD card interface. A little bit about the VGA controller setup. First, the VGA uses a 25 MHz clock, which is half the frequency of the system clock, so a PLL is needed. This creates a new clock signal in reference to the system clock, making sure that they both work together. In QSys, the FIFO, character buffer, scalar, sampler, and pixel buffer are all chained together to implement the VGA controller. The onboard SRAM is used to hold the pixel buffer. The main function of the assembly program is a simple loop. It first reads the SD card into the 512-byte buffer. A delay is used after that to make sure the display VGA controller has been properly set up, and then the buffer contents are read out to the VGA display. When this is done, an infinite loop has the program just sit. To read the SD card, I first had to find out exactly where on the card it was being stored. Using a hex reader, I found that my data file was stored in sector 768 of the card. Taking this number and multiplying it by 512 gave me the full address of the data file. A read command was sent to the card, along with the address. When the read command was done, the 512-byte buffer was full with the contents of the data file. Displaying a character on the monitor is as easy as writing to memory because of the VGA controller described earlier. I just needed to keep track of the cursor so the data doesn't get overwritten. 2 registers were used to store the X and Y coordinates of the cursor position, which was updated after each character was displayed on the screen. Checks are in place to make sure that there are only 80 characters per line and 512 characters total. And these are my references. 2 PDFs available online that greatly helped in designing this program.